to simplify. Now, I want you to look at all four of these problems. So let's just start with one you think you can do. Does anybody have an idea about any of these? Any four of these problems? Julia.
Like for the first one?
I'll number them. Yeah, for the first one, okay.
Can't you for the sine x squared minus 1, so then you can factor it and then cross it out?
Very good. She's got the entire problem planned out. She's got it figured out. She says, you know, Mrs. Ford, you want me to simplify this. This is a cosine, this is a sine. They don't cancel. What am I supposed to do? Then she remembers on her purple sheet, there is an identity that says sine squared plus cosine squared equals 1. And next to it or under it or somewhere, I had you write a couple of other things. What did I have you write right next to that identity? What did you write? What does cosine squared equal? Cosine squared equals 1 minus sine squared. So she's saying, let's take out this cosine squared and replace it with 1 minus sine squared. Perfect. Now, why would she be thinking to do that? Because something's got to cancel here, folks. If you're supposed to simplify this, something's got to cancel. And they don't cancel unless they're the same function. So she says, I got a way to switch cosine squared. So I'm going to do that into 1 minus sine squared. Now, does anybody other than Julia remember what's special about 1 minus sine squared? We talked about it the other day. It factors. This is the difference of squares. 1 minus sine squared will always factor. Suzanne? How does it factor?
1 plus sine.
1 plus sine, 1 minus sine. Gang, 1 minus anything squared, whether it's tangent squared, secant squared, doesn't matter. 1 minus anything squared is going to factor into 1 plus that thing, 1 minus that thing. Now, what is so wonderful about doing that? These two then cancel, right? So what is the answer to this question? 1 minus sine x. Does anyone have a question about one of those steps? Our goal is by the end of the week for you to be able to do that by yourself. We'll practice some every day. All right? Okay, let's look at this one. Or any of them now. We don't have to go in order. So does anybody see, Julia, that was very nicely done. Does anybody see anything about 2, 3, and 4 that you think you might could do? Brooke?
Tan equals secant squared x minus 1.
Down here?
Doesn't.
Well, be careful. You're thinking about an identity, which is a good identity to use, but it has to be squared. So I can't change my tangent. But what about secant squared minus 1? Let's look up here. If we rearranged this, doesn't it say that tangent squared equals secant squared minus 1? So instead of changing our tangent, let's take this guy and change him into tan squared. And then what's so awesome about changing him into tan squared? We have tangent squared over tangent, which reduces to tangent. Now, did anybody think when you looked at this problem, thinking about what we did over here, did anybody think about factoring this into secant plus 1, secant minus 1? Because you could do that. But what's kind of the downside of doing that? Nothing will cancel. And the whole purpose of factoring is to try to get things to cancel. So that would not be wrong, a wrong first step, but then you're kind of stuck. So I think Brooke's idea was better. We need to make these the same function. So we think about this identity. This is the identity right here. Yep. All right. Anybody have an idea for either one of the next two? Maya? Absolutely, you could rewrite cosine over sine as cotangent, but just kind of take a bigger look at the picture, or at the equation. What's going on here? What do you have? You can cancel right off the bat, so your answer is just cosine. So, Maya, it isn't a matter of what you said being wrong, because it wasn't wrong. It just wasn't the best option in terms of simplifying as far as we can. Okay, what do you want to do with number 4?
Change cosecant x into 1 over sine x and keep cosine. Change tangent to sine x over cosine.
Okay, so let's pause right there, Ethan. Ethan suggested, Gibran, my friend, what are you doing?
There's no Bible answer, you guys.
You're right, that's an email to your mom. Here we go. Ethan has suggested that we rewrite each of our functions in terms of sines and cosines. So, he has memorized from his purple sheet, or actually we learned this a long time ago, cosecant's 1 over sine. Notice now, when I wrote my cosine, I wrote it as a fraction. That helps me. You don't have to do that, but it helps me, because now I got a whole string of fractions. Tangent is sine over cosine. Now what happens when you look at that, Jack?
Is it just one? You can cancel everything.
The sines are going to cancel, the cosines are going to cancel, and you're exactly right, Jack. The whole mess boils down to 1. Okay?
Why is tangent sine over cosine?
All right, did anybody have a question about one of your homework problems last night? Do we need to do any of your law of sines problems? Because today we're going to work a little bit more on the law of sines. Anybody have a question? Well, I'll find out when I grade your quiz this time. All right, here is today's lesson. Here's today's lesson. Looks a lot like yesterday's. We are going to solve the triangle. And you remember from yesterday, what that means is we're going to find everything we don't already know. So it looks to me like I don't know angle B, and I don't know, I'm actually going to write it down. I don't know angle B, I don't know angle C, and I don't know side B.
Wait, where are we at?
Yeah, we're ready.
Oh, you know what? You're right. Let's use your note sheets.
This is on our.
Oh, it's right here.
Except we have
Actually, no. Forget this. I forgot about the note sheets. We're on page 41. And we are going to draw a picture of triangle 2A. It says A is 20 degrees, side A is 12, side B is 31. Now, I have drawn a picture from data. This is page 41, problem 2A. it says angle A is 20. Side A is 12. And side B is 31. Now, when you draw your own triangle, you can arrange A, B, and C any way you want them. But make sure that wherever you put angle A, you put the 12 across from it. So if you put angle A at the top of your picture, that would be okay, as long as you put the 12 down here. Okay? There's nothing magical about where the A, B, and C are. You just have to make sure you have the right sides lined up with the right angles. Do you understand what I'm saying? Okay, so I've drawn this one. Now, I'm going to pretend, now the directions are a little bit different and they don't even make sense to you yet. I'm going to pretend that the directions say solve the triangle, just like they did on your quiz. Okay? So what would you set up here, your law of sines, if you were going to solve this triangle?
Sine 20 over 12.
Sine 20 over 12 equals?
Sine
Sine 12 is 12 sines.
Sine B over 31. That's perfect. The only pair you know is right here, so you go ahead and set that up. Sine 20 over 12. The only other information you have is this, so you have to say sine B over 31, don't you? So let's cross multiply. And divide. Now I think you see how this is a little bit different than yesterday. What am I solving for? I can type this in on my calculator, but I'm looking for an angle, right? So here's what I want you to do. I want you to go ahead and type in 31 sine 20, don't forget to close the parentheses there, divided by 12. Now, did you get a decimal? Now, that says that sine B is this, right? That decimal. How do I get angle B? That's what I want. I don't want the sine. I want to know actually what is the angle. I raise that, or not raise that, I do second sine that number, right? Now, listen to me. Here's how I want you to do this. I want you to press second sine, second answer. If you've got a nice calculator, if you've got the calculator you're supposed to have, I want you to press second sine, second answer. So second sine, second, it's the opposite sign, the minus sign down by the enter button. And hit enter. And how big did that turn out to be? 62.07. So angle B is 62.07. Type in this fraction, and then press second sine, second answer. And when I use my answer button, boys and girls, what does that help me? How does that help me? I don't have to retype the number back in. And that's good news, because when you retype it in, you'll round it off. This will be more exact. So we use our answer button. Instead of retyping, we just use our answer button every time. Okay? Now, here is where the excitement comes in. So I want you to put your calculators down for a minute, because I have something important to share with you. And I need your attention. So we're going to do some more. You can figure that out. I really need you paying attention here. When this happens, when you use the law of sines to find an angle, listen, when you use the law of sines to find an angle, you must over to the side, redraw your given information. There's my given information. And then put the supplement of the answer you got on your calculator in this spot. Okay, now time out. What do I mean by supplement? Who remembers? Supplementary angles back in geometry.
Oh, adds up to 180.
Adds up to 180. Very good, Jabron. So we said this one was 6207. So the supplement would be 117.93. This is called the ambiguous case. I'm going to go back through it in a minute. Here's what's happened. The given information in the problem was this angle, this side, and this side. Back in geometry, you had all kinds of postulates to prove triangles congruent. You had side angle side. You had side side side. You had side angle angle. You had all kinds of them. But there was one combination of letters you were not allowed to use. You were not allowed to use it because it made a bad word. I'm on video, so I'm not going to write the bad word. I'll write it in reverse. You were not allowed to use that combination. Remember that? You weren't allowed to use that combination. Kids, that's what you have here. You have angle side side. This is called the ambiguous case. And what it means to be ambiguous is it's unclear. When you are given ASS, angle side side, you don't know if you have one solution, two solutions, or no solutions. So you just set it up like every other problem, and you found that you got an answer. That means there's a solution at least. But then you've got to check to see if there are two solutions. Can you have a triangle that's a 20 and a 117? Yes, because the only rule about angles is they have to be less than 180, right? This is good. This triangle has two solutions. Now, let me go back through that. Let me go back through that and try to see. We're going to do some more examples. I know your head's about ready to explode. Here's what happens. You don't know, when you find this triangle laying in the hallway, you have no idea. You just know, I have to solve it. So you set up your law of sines. When this happens, when the variable is an angle, this puts you on alert. So you just go ahead and solve it, and you got an answer. We're going to do another one in a minute, just like it. Perfect. But then, because you're on alert, you've got to step over and say, okay, could there be two answers? If there are two, you don't have to do any more work. The second one, the second angle B, will always be 180 minus the first one. So you did regular work, got 62, so this would be 118. 118. Now, I want to show you something. If this had come out to be 167, it didn't. But if it did come out to be 167, do you see a problem? What's the problem? It's more than 180. So this would be a case where that one didn't work and there would be just the original answer that you found. In our example, the second answer also worked, was possible, so we have two possible solutions. I heard Bryce say, but which one's right? They're both right. So the good news is, I'm not making you solve both triangles. I am making you simply tell me there are two different triangles. What?
That's why it's asking.
Yes, that's why it said how many triangles are there. Okay, now I want the whining to stop, and we're going to look at the next one. The answer is 2. 2 triangles. Now, I want you to pretend that you came upon this triangle and you need to solve it. Okay? Now, I'm going to find angle B because my setup is sine 76 over 18 equals sine B over 20. This puts me on alert, which is why I drew the second triangle. Because there could be 2, like there were in our last problem. There could also be just 1, and actually there could be none. We'll find one of those here shortly. So I have it set up to solve it. So we'll cross multiply. Everybody okay with the setup? Sine 76 over 18?
Yes. The rest of them.
All right, here's what I want to do. I need to modify your assignment. Here's what I need you to do. Homework tonight, real easy. Finish this problem. Do the best you can. See if you can figure out how to finish this problem. That's your whole assignment. One problem. Finish this assignment. Finish this problem in your packet. Okay? Katie, would you please? Yeah, of course. My iPad.